Morning to one and all. Today our topic is the unit 1 last topic, that is overview of grid architecture. That is the model, in the sense which model. That model name is hourglass model. It focuses on architecture issues. Okay, it proposes set of core services as basic infrastructures. It is used to construct high level and domain specific solutions. Like we have to see in here, design principles keep participation cost low, and it enables local control, and it support for adaptation and internet protocol hourglass model. More specifically, what we say, in the sense, grid computing environment can be viewed as a computing setup constituted by a number of logical hierarchical layers. Okay, here we have discussed the layers, grid computing layers also. It represents it represent in it including grid fabric resources and grid security infrastructures and core grid middleware, and one more user level middleware, and the last one resource aggregators. The grid programming environment and the tools and grid applications. The major constituents of grid computing can be identified into various categories from different perspectives. We want to see in a functional view, physical view, and service view. These are the basic concepts of a grid from a functional view. It decided depending on the grid design, and it expected to use some of the functional constituents of a grid. Okay, we have security, resource broker, scheduler, data management, and job and resource management, and resources. Okay. And coming to the grid architecture, what is grid architecture? We have seen now an overview of grid architecture. Overview here: the computing element is a set of G-Lite services that provides access for grid jobs to a local resource management systems, nothing but batch systems running on a computer farm, or possibly to computing resources local to the computing element host. Typically, the computing element provides access to a set of job queues within the local resource management system. What is a resource? First of all, we have to learn that a resource is nothing but it is an entity that is to be shared. This includes computers, storage, data, and software. A resource need not be a physical entity. Normally, grid portal acts as a user interaction mechanism, which is application specific, and it can take many forms. Okay, a user security functional block usually exist in the grid environment, and it is a key requirement for grid computing. Here, utilization period, booking conditions, and no particular booking is required to use the service. However, the user must have a valid grid certificate of an accepted certificate authority, and it must be a member of a valid virtual organization. Okay, in a grid environment, there is a need for mechanism to provide authentication, authorization, data confidentiality, and data integrity and availability. Particularly from a user point of view, in the case of interdomain grids, there is also a requirement to support security across organizational boundaries. Okay, so this makes a centrally managed security system impractical. Okay, the service is initiated by respective commands that can be submitted from any G-Lite services user interface, either interactively or through batch submission. What we want to say, in the sense, the grid security infrastructure, this makes a centrally managed security system. It provides a single sign-on, run anywhere authentication service with support for local control over access rights and mapping from from global to local identities. Okay, what we want to see in the grid architecture in the sense, to run a particular job on the cluster, the user must install and own at least have access to a G-Lite user interface. Certificates can be requested. For example, at the German Grid Certificate Authority, deregistration, no particular deregistration is required for this service. A user with an expired grid certificate or virtual organization membership is automatically blocked from accessing the computing element. In the sense, what we want to say in the IT security, the architecture of a grid system is often described in terms of layers, each providing a specific function. Okay, here the database and log files of the computing elements, it contain information on the status and results of the jobs and the certificate that was used to initiate the task. The required data files themselves are stored on the worker nodes in the grid storage elements. No other personal data is stored. We have some technical requirements to run a job at the grid cluster of the Stein Bus Center. For computing the user needs, a valid grid user certificate is available and membership in a virtual organization is needed at one or at least access to a user interface. This is the architecture of grid, overview of a grid, the system, web based grid control and hypertext transfer protocols to a service, web management service. The web applications are running in the service, and JDBC is connected to the management repositories, and both bidirectional of management agents, and it will be lost, will be transmitted the third party applications and application servers control and application server and database control and databases. And we have seen the layered grid architectures. Here very important topic, the grid layer architecture. Here we have seen higher layers are user centric, whereas the lower layers are hardware centric. Okay, we depict this picture, a generic grid architecture showing the functionalities of each layer here. Okay, here the layered grid architecture, it coordinating multiple resources, ubiquitous, it's widely spread infrastructure services, application specific distributed services. Here what we want to say, coming to the application layer, which includes different user applications, science, engineering, businesses and financials and portal and development toolkits. It's supporting application. Okay, these are the internet protocol architecture. What we want to collective layer and resource layer. What in a network layer we want to, these the network layer. Okay, network layer is the bottom layer which assure the connectivity of the resources in the grid. What we want to collect in the internet network. Okay, coming to the resource layer, what we have to what exactly, in the sense it is made up of actual resources that are part of the grid, such as computers, storage systems and electronic data catalogs, and even sensors such as telescopes or other instruments which can be connected directly to the network. Okay, sharing single resources, negotiating access, it controlling use. Okay, talking to things is nothing but communication, in the sense internet protocols and security, what we have to connectivity. Okay, controlling things locally, it access to and control of resources. Okay, we have seen here middleware layer in the sense middleware. In the application layer we have some middle layer, network layer. Okay, in middle layer it provides the tools that enable various elements like servers, storage, networks, etc. to participate in a unified grid environment. Okay, unified grid environment. And we have seen here and we have seen the fabric in the sense link layer. What we have to link? Data link layer. The data will be linked, okay, through a internet protocol address, okay. And we have seen the layered grid architecture. What are the main characteristics of grids we have seen? Okay, main characteristics of grids I want to explain. Okay, main characteristics of grids in the sense, the main characteristic of a grid computing environment, we have some basic terminologies we have to use here. First one is large scale. In the sense, a grid must be able to deal with a number of resources ranging from just a few to millions, okay. Coming to the geographical distribution, in the sense, grid resource may be spread geographically. And coming to one more, heterogeneity. In the sense, a grid hosts both software and hardware resources that can be ranging from data and files and software components or programs to sensors and scientific instruments. And one more, display devices, personal digital organizers, computers and supercomputers and networks. Here, very main characteristic of grid is resource sharing and coordination. What is resource sharing and coordination? In the sense, resources in a grid, it belongs to different organizations that allow other organizations, that is users, to access them. The resources must be coordinated in order to provide aggregated computing capabilities, okay. And coming to the multiple administration is the main key characteristic of a grid. Here, each organization may establish different security and administrative policies under which resource can be accessed and used. The last main characteristic of a grid is accessibility attributes. What we have to access: transparency, dependability, and pervasiveness. In the sense, spreading widely throughout an area via internet or attributes are typically to grid resource access. Here, a grid should be seen as a single virtual computing environment, okay. And it must make sure that delivery of services under established quality of service requirements. So a grid must be built with standard services like protocols and interfaces, services, hiding the heterogeneity of the resources. While I am talking allowing its scalability, a grid must grant access to available resources by adapting to dynamic environments where resource failure is common, okay. These are the main characteristics of grids. Thank you, one and all.